Okay, so metric conversions, don't you just love this stuff? You know, if you go to a country like Canada, or if you go to a country in Europe, I guess, I've never been to Europe, but the people there bounce back and forth with measurements a lot quicker than we do in the English system. Like, for instance, if you're going to go from feet to inches, you know, that's a factor of 12. Not everybody walks around with 12s off the top of their head. And if we're going to go inches and yards, that's 36. And if we're going to go pints to gallons, that's 8, let alone bushels. I don't even know exactly what a bushel is. So this is a very, very different sort of thing. See, when I was a kid and we were in school, they told us the whole world was going to go metric. And I think the only two things that are not metric are England and the United States. Maybe there are other countries, but if there are not many. And the truth is, I don't think we'll ever all go metric, because then all the manufacturing and all the machines have to be replaced from making English measurements to making metric measurements. And I just don't think companies want to invest that kind of money. But let's be perfectly clear. The metric system is way easier to operate in. Let me just show you how much easier, okay? I'm going to show you the technique that we used when I didn't use it per se, but this is the technique that's taught in the school district that I taught in. And then we would piggyback on this every once in a while and refer to it for the kids. So first off, you don't usually deal with mega, giga, or tetra very often. Typically you deal with kilo, hecto, deca, then whatever the unit is, deci, centi, and milli. Those are the most common ones, okay? And those abbreviations, if you just look at the first letters, kilo, K, hecto, H, deca, DA is what they use for the abbreviation there. You can see it in the blue column at the top. Deci is a little d, centi, C, and milli is M. So what we got here is King Hector died drinking deadly cough medicine. They all line up, see? K, H, D, and so on. So if you just remember, King Hector died drinking deadly cough medicine. So back in the day when you weren't allowed to have like a table to help you out, like you could take a picture of this if you want, no problem. We would remember that. King Hector died drinking deadly cough medicine. And then what that would allow us to do is if I wanted to convert 5.2 kilometers to centimeters, I would just put, now the decimal point always goes on the right-hand side of the column we're talking about, which is kilometers. So on the right-hand side of the K column would go where the decimal point would originate. That's 5, and then we would have had a point here, 2. And then I want to go 2 centimeters, so I just fill out zeros until I get to the centimeter place, which is right here. And that's my answer. I don't have to do anything. I just 520000, 520000. Done, fini, that's it. There's nothing else to it. Now, you could go in either direction. You could go from a big to a small, where you would, of course, end up multiplying. Or you could go from a small to a big, which you would, of course, end up dividing. So let's do 3 centimeters to meters. I'll take the lead on this. So 3 centimeters, put the 3 so that on the right-hand edge of that center column was where the decimal point would go. And then I move the decimal point to the right-hand edge of the meters column. 1, 2. Here's the right-hand half of the meters column. It says differs up there, but all it is the units you're talking about. So the decimal point goes there. So the answer is 0.03. Simple as that. You try the next one. Okay, so let's put the 4.5 in the centimeter place. There's the 4 point right-hand side. 5 is in the milli place, so that's it, 4.5. And then fill out zeros all the way until we get to the kilometer place. Put the decimal on the right-hand side of the kilometer place, and that's 1, 2, 3, 4 decimals and a 45. 1, 2, 3, 4 decimals, 45. Remember, the decimal always in the answer goes in the right-hand part, right-hand column of the, in this case, kilo, wherever they're asking for. All right, now let's do 8.3 hectometers to decimeters. I also know it's decimeters because deci is the little d and deca is dA. Okay, so I put the 8.3 Here's the 8 in the hectocolumn, and then the point on the right-hand side, and then 3, and then I have to fill out zeros until I get to deci, which is right here. So that would be 8300 or 8300. So that's King Hector died drinking deadly cough medicine, the metric conversions, and you just fill in the spaces and go from there. If you talk to someone learning it from a foreign country like Canada, you can literally see their eyes like watching a cartoon following the bouncing ball as it goes across. It is quick and easy, and there's no division or multiplication to follow it. It's just sliding the decimal left and right. Okay. Now, there's also times where you have to convert between the US system and the metric system. And look, there is no difference between converting between the US dollar and other currencies of dollar, or the US way of measuring and other currencies and a way of measuring. The only thing that changes is the factors, but the way you do the problems, well, that's the same. So here's the question. How many square miles are in 5 square kilometers? Okay. Give it a shot. See if you can do it without me. Then I'll come through and show you the answer. Now, 1 kilometer is 0.6214 miles. So 1 kilometer squared is going to be 0.6214 miles squared. And if I just do that multiplication, I get about 0.3861 miles squared. How else could you do it? Well, oh, and then we go to 5 kilometers squared is 5 times 0.3861, because each square kilometer is that many square miles, and I get 1.9305 square miles. Okay, next up, let's see, you use those conversion charts, which, let me go back to that for 1 second. Oh. You should take a picture of this for your phone so that if you ever need the conversion factor, you have it laying around. Okay, now try it. Go ahead. Okay, so let's go meters to feet. A meter is clearly bigger than your feet. So there's a factor of 3.28 according to that chart. So if I want to go 10 meters to feet, it's 10 times 3.28 or 32.8. What about 150 pounds to kilograms? Go ahead. So a pound is smaller than a kilogram. So again, the factor is 0.4536. That's the factor between pounds to kilograms. And because you're multiplying by 0.4536, you're actually, in a sense, dividing, because this could also be 1 over 2.2. I know that's a little confusing, but I looked up the factor, so I am going to multiply, and what they said in the conversion chart is 0.4536. So 150 times 0.4536 is 68.04. And that seems reasonable because it says in the chart that a kilogram is a little less than half of a pound. And 150, if I cut it in half, would be 75, so it's a little less than 75. What about 1,200 square feet, 2 square meters? Well, feet are definitely smaller than meters, but you look up the factor because it gives you the conversion factor of 0.3048. So 1,200 times 0.3048, and then because it's squared, you have to do 0.3048 a second time, or just do 0.3048 squared. And that gives you 111.48. So there are your conversions between metric and English system, English and metric system. You don't see it done too often. It's not the dominant thing. Usually you either operate in the metric system or you operate in the English system. You don't usually cross over. But if you have to, it can be done. And that's what those conversions were all about. Now, the last conversions, I think that we have to do temperature, and then we have to get into density real quick. Temperature conversions from Celsius to Fahrenheit, Fahrenheit to Celsius, Celsius to Kelvin, Kelvin to Celsius. First off, as regards Kelvin, I have been around. Look, I got some powerful degrees, and my degree is in math and also in physics. And I got to tell you something. outside of like a really specific science application, in the 36 or let me see, I graduated college in 85. So yeah, the 36 going on 37 years I've been out of college, I have used Kelvin once. I believe it was on the game show Jeopardy. Okay, so that I wouldn't worry too much about Kelvin. I really wouldn't. Now Celsius to Fahrenheit and Fahrenheit to Celsius. Now that's a different deal. But here's the thing: I don't like to remember two different formulas. I like to remember one formula only, and that formula that I like to remember is that Fahrenheit is 9/5 C plus 32. You could also say 1.8 because 9/5 is equal to 1.8. Okay, so Fahrenheit is 9/5 C plus 32. And then you just plug in for whatever they give you. You substitute. So if they convert 20 degrees to Celsius, put a 20 into for C and then figure out the number. Go ahead. Now, if you do this with a calculator, you can put in the fraction 9/5, and on a graphing calculator, that's alpha y equals, and then you'll see the fraction template come up. Or you can make it 1.8, just do 9 divided by 5, you get 1.8 times, Celsius in this case is 20. Or you could do 9 times 20 divided by 5, all work, and then plus 32. So if I do that, I come out with 36 plus 32, which is 68. Now, you know the answer to 72 degrees Fahrenheit to Celsius, converting in the other direction, should be just slightly bigger than 20, right? Why do a second formula? I hate formula. I don't want formulas jamming my brain. The formula F equals 9/5 C plus 32, that makes a lot of sense to me because when the Celsius temperature is 0, the Fahrenheit is 32. So that's easy to remember, the plus 32. And then I always just remember 9/5, but you could just remember 1.8 and plug that in there too. So convert 72 degrees to Celsius, start with the same formula. Okay? But this time you plug in a 72 for the Fahrenheit. Now, solve for C. Go ahead. So, you're going to subtract 32 from both sides, and I get 40 equals 9/5 C, or 1.8 C if you want to write that. Divide by 9/5 or 1.8, whatever you prefer. Same exact thing. And I get Celsius is 22.2 degrees. So you can use the same formula to go back and forth. And in my mind, I don't like using more, or I don't like having to remember more formulas than necessary. Density and concentration. Density describes how compact or crowded things are with molecules. So material density is given in terms of mass per unit volume. Okay, for example, grams per centimeters cubed. And population density is the number of people per a unit area. Concentration describes the amount of one substance mixed with another. For example, with air pollution, you can measure it by the number of molecules of the pollutant per million molecules of air, or your blood alcohol content. I certainly hope you would never drink and drive. My knee got destroyed by a drunk driver. My uncle was killed by a drunk driver. And they measure if you are driving impaired with blood alcohol content. It's measured in terms of the units of the grams of alcohol per 100 milliliters of blood. Now, here's an example. A 40-gram pebble has a volume of 10 cubic centimeters. What is its density? Well, let's just work through the whole thing step by step. We don't need to bring the slide in one at a time. Density is mass divided by volume. So in this case, the density is 40 grams divided by 10 cubic centimeters, cc's. 40 divided by 10 is 4, so the density is 4 grams per centimeter cubed. The density of water is just about 1 gram per centimeter cubed, so you can bet the pebble will sink. It is more dense. And last but not least, New Jersey and Wyoming have areas of 7,419 for Jersey square miles and 97,105 in Wyoming square miles, respectively. I would rather go to Wyoming and do some trout fishing. I love trout fishing. The corresponding populations are 8,400,000 and 490,000, respectively. Okay, calculate and compare their population densities. So go ahead, try Jersey first. We actually have 2 of them to do here, so it's good practice. Okay, so Jersey is going to be 8,400,000 people divided by 7,419 square miles. And that gives you great people from the state of New Jersey, 1,132 people per square mile. Being a huge Bruce Springsteen fan, I am very into the whole Jersey concept. What if I went to Wyoming? Well, being a big Wyoming fan because of the fly fishing, I really appreciate the lack of density. There you have 490,000 people divided by 97,105 square miles, and that's a little bit over 5 people per square mile. Now, that's more my way of being. I kind of like that kind of existence. This is a nice thing. So, population density working itself out. All right, how do I compare them? New Jersey's got a lot more people in it. All you got to do is look at the traffic to know that. All right. Bruce Springsteen never could have written Saint in the City if he had been born in Wyoming. That's my big conclusion, right? Saint in the City is all about a crowded, congested area with the subways. So the population density is far less in Wyoming. All right, have a great day, guys.